Finding the x-intercept of a line. So far, we've been finding the y-intercept of a function, the point at which the graph of the function crosses the y-axis. Recall that a function may also have an x-intercept, which is the x-coordinate of the point where the graph of the function crosses the x-axis. In other words, it is the input value when the output value is 0. To find the x-intercept, we set a function f of x equal to 0 and solve for the value of x. So for example, we're going to consider the function shown, f of x, which is equal to 3x minus 6. And so what we're doing here is we're going to replace this f of x, to be 0. So that means now that becomes 0, and then we're solving for 3x minus 6 is equal to 0 to solve for x. So we add 6 to both sides, divide both sides by 3, and therefore x is equal to 2. And so the ordered pair would then be 2, 0. So the graph of the function crosses the x-axis at the point 2, 0. Now, the question states that do all linear functions have x-intercepts? Well, the answer is no. However, linear functions of the form y equals c, where c is a non-zero real number, are the only examples of linear functions with no x-intercept. For example, y is equal to 5 is a horizontal line 5 units above the x-axis. This function has no x-intercepts, as you can see here in figure 21. So it passes through the y-axis, but it never touches the x-axis. So an x-intercept, the x-intercept of the function is the value of x when f of x is equal to 0. And it can be solved by the equation 0, which is equal to mx plus